Hi there! In this video we're going to talk about extended angles and triangles. So in order to talk about it, we first have to know what is an extended angle. So an extended angle is literally an angle that's outside of the triangle, and you make this angle by literally extending the side of the triangle. So I drew it out for you, and I drew out 3 different extended angles, or what we call exterior angles. So if I take this bottom side, so if I look at my, let's just pick green. Okay, so if I focus on my triangle here, so here's my triangle, and I extend the side, so well, I think red's good. Then I just draw my side out to this pink line. I now have this angle right here, which is an extended angle of my triangle. And you can do this on each side of the triangle. So I can extend out this side here, which makes this what we call exterior angle. And I can extend out this side here, which makes this exterior angle. You can kind of look at it. If you look at it just with the 3 extensions, it almost kind of looks like a windmill effect. But that's what it means to have an exterior angle or an extended side. So I drew out another picture for you here so that we can get a little bit of vocabulary out of the way. So I already mentioned the word exterior angle. So if I extend out my side, I have this angle out here that is an exterior angle. I literally call it an exterior angle because it's an angle that's on the exterior or the outside of my triangle. Then I have these 2 angles that are not connected. So I have this angle right here, which would be my angle that's adjacent, which means next to my exterior angle. And then I have these angles over here that are green that I labeled 55 degrees and 45 degrees. These 2 angles right here that are not connected to my exterior angle are what we call remote interior angles. So I just want to kind of go through a little example so that we can see how these 2 are related. So we know 2 things, right? We know we're going to use that all the angles in a triangle add up to 180 degrees. So if I wanted to find this missing angle right here, I can use the fact that all these in the triangle add up to 180 degrees. So I could say that 55 plus 45 plus x equals 180 degrees. I can combine together my like terms. So I get that 55 plus 45 is equal to 100 plus x is equal to 180. If I subtract 100 from both sides, I get x is equal to 80. Okay, now here's what else I know. If I just say wanted to use this part, then I know that angles that make a straight line add up to 180. I could say that if I'm using these 2 angles right here, that x plus 100 is equal to 180. And I subtract 100 from both sides. I also get x is equal to 80. Okay? So it should make sense from both sides that all the angles in a triangle add up to 180 and that my angles that are a linear pair or that are adjacent on a straight line, which means next to each other on a straight line, also add up to 180. So now what is the relationship between these remote interior angles and this exterior angle? So I'm just going to erase some of this stuff so it's out of the way. Okay. So what's the relationship between these 2 guys and this guy? Well, we learned down here that when we added up 55 plus 45, it equaled 100. And look at, this is equal to 100 and this is equal to 100. So we know that the sum of the remote interior angles is going to equal the measure of the exterior angle. Now, most of the time, you're going to be able to solve problems without using this fact about remote interior angles and exterior angles, but it's a handy piece of information to know because it can save you some steps. So I have a couple examples for you that we are talking about exterior angles where we need to find the missing value. First one, find x. So I can do this a couple different ways. I can use my thing that I just learned, that the sum of my remote interior angles is equal to my exterior angle. So let's do it that way first. So my remote interior angles, what color did I use for those? Green. So my remote interior angles are these ones, and my exterior angle I originally used as pink. So I take my greens, I add them together to equal my pink. So I know that x plus 102 is equal to 136. I can solve for x by getting rid of this 102 or subtracting 102 from each side. You can use a calculator if you need to, and you end up with x is equal to 34. Now, if you didn't know that handy trick, you could go in and you could say, all right, here's what I do know. I know that these two angles right here make a straight line and they add up to 180. So I could say 136 plus, I'm going to call this y, equals 180. I have to subtract 136 from both sides because I need to get my y on a side by itself. So I get 180 minus 136 gives me 44. So I know that this angle right here is 44. Now I know that in my triangle that I have, this guy right here, all my angles have to add up to 180. So I could say that 44 plus x plus 102 would add up to 180. I'm going to combine together my like terms, which would be 44 here and 102 here. So 44 plus 102 is going to give me 146. Plus x is equal to 180. And then I need to get x on the side by itself. So the opposite of positive 146 is negative 146. So I subtract 146 from both sides and I'm totally running out of space. 180 minus 146 gives me 34. Ta-da! That's what I got right here. So you can see that using that sum of remote interior angles equaling the exterior angle is significantly quicker, but it does give me the same answer. Okay, let's try this guy right here. We can go again about this in the same method, except this time we're going to have to maybe do it a little bit backwards. So let's first not use the trick that we know. So first I know that all my angles in a triangle add up to 180 degrees. Why do I have to do that first? Why can't I do this first right here? Well, because I don't know that guy either. That's what I have to try to find. So when you're looking at these kind of problems, you have to see what do I know and what can I find from what I know. Here, I only see that I can have information to find this missing piece right here, this y. Okay, I called it y and not x because I already have an x. So first I'm going to find this missing piece and then I can find my x value. So I know that all angles in a triangle add up to 180 degrees. So I can say that 37 plus 87 plus my y adds up to 180 degrees. I combine together my like terms. 37 plus 87 gives me 124 plus y is equal to 180, and then I have to get y on a side by itself, so I subtract 124 from both sides. Oh, and I'm running out of space again, so I get y equals 180 minus 124 gives me 56. So I figured out that this angle right here is equal to 56. Now I know that these two angles make a straight line, so they're going to add up to 180 degrees. So I can say that 56, that's a funny looking 6, plus x is equal to 180, and I'm going to subtract 56 from both sides to get x on a side by itself. And I get x is equal to 180 minus 56, or 124. Okay. Now, that sounds a little bit familiar, because if I use the fact that the sum of my remote interior angles equals my exterior angle, remember I can say that my remote interior angles added together equals my exterior angle. 37 plus 87 equals x. I already added those together right here, and I know the answer is 124. See how this method can save you some time? All right, I want you to try one last example here. And I want you to only do it using the fact that the sum of the remote interior angles equals your exterior angle. Stop the video right now, try it on your own. I'm going to work it out, and then you can see if you got it right. So, the sum of the remote interior angles is equal to my exterior angle. So x plus 57 is equal to 134. I have to get x on a side by itself. The opposite of positive 57 is negative 57, so I'm going to subtract 57 from both sides. I get 134 minus 57 is equal to 77, so x is equal to 77 degrees. How'd you do? I hope that you got it right. If you have any questions about how this works, please let me know. Good luck.